Hi friends, we are working on directory. It's a data structure used to map the keys to the values, and we are stuck up the war between space and time. And if we had infinite space available, then we could have used something like a bit array, bitmaps, and made sure that the writing, reading, updating, creating, deleting, all can be done at a constant time or unit time. And on the other hand, if we had infinite time and were having limited memory or the limited space, because in this case we assume the space was infinite, which is not practically possible. Therefore, we would like to see what is practically possible. So in practice, memory or the space is indeed limited. So we need to verify how to work with a limited space situation. So now, if we assume that time is no more a constraint, then yes, we can use a limited memory and form a list and space, store the data in the consecutive locations. And with this, uh, we will not be able to retrieve the data in unit time. But yeah, if time is no more a constraint, so we can think of making a list. And if it is an unordered list, so we can go for a linear search, which is order of n. Or if we can somehow make it ordered, then we can go for binary search, which is order of log n. So that's all we had already seen. Now the question always arises is after looking at this logic, can we somehow make sure to get the results in almost constant time? So constant time, the moment we say, we think of infinite space, but no, at the same time, if there is finite space. So is it possible, was the question we had asked in our previous session, and the answer was yes, it is possible through something called dictionary. It's a hash table. So the process of doing this is called hashing. So here we are trying to optimize both in space as well as in time. So what is the logic? So let's assume finite memory. So these are our locations. So if we add one more, that would be better, I hope. Yeah. So that, oh, I'm sorry. It's right, 0 to 18, which are having a total 19 locations. Okay. So we are working with a situation where we have limited number of locations, and now we would like to store the data into this. So how we can store that, and at the same time make sure that we can retrieve the data at constant time. So that's a process called hashing. So what we do is instead of using this address directly, the key value is converted into an index of this using some hash function. So h of k is a hash function. So when we give the key to the function, it finds an index, and this index happens to be between 0 and 18 in our case. So the easiest way of working on that is key 19. So that's our index. So find the remainder after dividing 19. So when you do modulo operation with 19, then the results are going to be 0 through 18 only. And so how this helps us in solving the problem? Yeah, let's try to see. I want to save 20. The list is of, say, size 20, then 30, then 40 are the three numbers want to save in this. So when you say 20, then we find 20 modulo 19, and the answer is 1. So the index is 1. So the value 20 is stored here. Done. Second thing is 30 modulo 19. So 19 ones are 19, 19 twos are 38. So not possible. Therefore, it's 19 ones are 19. So what is remaining is 11. So on the 11th position, you write down 30. Then comes 40. 40 modulo 19 is 19 twos are 38. So that makes remainder equal to 2. So add 40 at location 2. So for inserting data, what you need to do modulo operations, and that's going to take a constant time. Yeah, one number modulo operation, so it's going to constant time. Then if you want to retrieve, so I want to verify whether 20 is there in my list or not. So what should I do? Just 20 modulo 19, that says 1. Go to 1 and see is there 20 or not. Yes, of course 20 is there. So the answer is found. Yes, it do exist. Otherwise, if you try to find 25, is 25 there in our list? So 25 mod 19, it is 6. And go to location 6 and see that it is blank. You don't find a 25 there, so you can confidently say not found. So for find retrieving, what operation you do? Again, you just do mod operation, and that also takes a constant time. So we succeeded in working in constant time. So final, you can say, succeeded in working in finite time. I am sorry, it should not be finite time. It should be constant time. So the order of n, order of log n was finite itself. So no, it is constant time on a finite space system. So the data structure is a finite space, and still we could work in a constant time. So that's the advantage of working on hash tables or the hash function. So now the question is, what if number was 39? 39 modulo 19. So 39 modulo 19, so 19 2s are 38, so remainder is going to be 1. So we would like to store 39 at location 1, whereas location 1 is already occupied, and hence, so this is not possible to insert. Why? Because this location is already occupied. Then is there any solution for this problem? So it's not necessary that these all numbers you are going to get only once, because we are working on modulo operation. So you can give any number x and talk of modulo 19. Then it's not necessary that there should be only 19 numbers in your thing, and each number gives a different modulo result. So it's definitely not possible. Even if there are only 19 numbers in your list, it is not necessary that each number should give a unique remainder. It is possible that all 19 numbers may give the same remainder. Then all 19 are going to use the same location, which is not possible. Then what is the question? So when you are having multiple data resulting in same remainder, then what is the solution? So yes, we have some solutions for this problem. Yeah, little extra work is required, but definitely not in terms of log n or order of n. It's definitely again a constant time, but little extra compared to this. And what that is, how we can solve this is issue we are going to discuss in our next session. Thank you.